stellar. We are a community whose members, blah, 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 blah. Thought I'd catch you off guard tonight. Trying to come up with that catchphrase, right? So today we're going to talk more about segments in triangles and triangle properties. And we're going to talk about the inequalities that can exist within a triangle. So we're going to talk about the comparison property of inequalities. We're going to talk about a corollary to the remote angle theorem, and then look at the relationships between the sides and the angles. So what's the comparison property of inequality? It basically says that if A equals B plus C and C is greater than 0, then A is greater than B, which if you think about it really makes sense. So if I know that, for example, 5 is equal to 3 plus 2 and C isn't equal to 0, if we plug those in, then none of those numbers can be greater than 5. So remember the triangle remote exterior angle theorem that we learned in a previous chapter said that the measure of angle 1 plus the measure of angle 2 is going to equal that measure of angle 3, our exterior angle, and then our remote interiors. Well, corollary, remember, is just kind of like an adding on to the proof. And so it says that the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. Again, that makes sense based on the comparison property of inequalities. If you think I can't yell at you when I'm doing this, think again. All right. So 1 cannot be bigger than 3, and the measure of angle 2 cannot be bigger than 3. So let's take a look. Why is the measure of angle 2 greater than the measure of angle 3 in this drawing we have? Okay. Well, because we've got the markings, we can see that BC is congruent to DC, which makes it an isosceles triangle. So that means that the measure of angle 1 is going to be equal to the measure of angle 2. Now 1 is an exterior angle to triangle ABCD. Okay? And therefore, we know that the measure of angle 1 is going to be equal to the measure of angle 3 plus the measure of angle 4. Okay? Now 3 is remote exterior, so 3 is going to be less than angle 1 because it is that remote interior, and we just had that theorem. And we then, since 1 and 2 are congruent, can substitute in angle 2. So the measure of angle 3 is going to be greater than the measure, or sorry, I screwed that up, guys. The measure of angle 1 measure of angle 3 is going to be less than the measure of angle 2. I just wrote it backwards. All right. Moving on. Okay, we have more theorems. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side, and vice versa. If the two angles of a triangle are not congruent, then the longer side lies opposite the longer angle. So when I'm looking at this triangle PSU that I have here, I've got 12 centimeters for side PS. That's my smallest side, which means that angle U is my smallest angle. And then I've got the largest side is SU, so the angle opposite, so the one that's not part of that side, is angle P, and angle P would then be the largest. So I've got my smallest angle opposite my smallest side and my largest angle opposite my largest side. So now let's list our sides of triangle PQR in order from shortest to longest. So my smallest angle is 45 degrees, so it's opposite side QR, so I'm going to have QR as my shortest. Then my next angle is angle R, which was 55, and it's opposite QP, so that's my middle angle. and then my last angle is 80 degrees, and the side opposite that is PR. So my order from shortest to longest is QR, then QP, and then PR. One more example. In triangle SOX, the measure of angle S is 24. The measure of angle O is 130. And we want to know which side is the shortest. Well, we don't know what angle X is, but since the sum of the angles of a triangle is 180 degrees, we could add those up, and we would get 154 already. And then 180 minus 54 is going to give us 26. So our shortest side is going to be side OX. So our smallest is OX because it is opposite the side that is 24. We have the triangle inequality theorem that says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So we want to determine if we can have a triangle that has the side lengths given. So we have to take the two shorter sides, we have to add them together, and decide if it's bigger than the largest side. So 2 plus 6 needs to be greater than 9. So 8 is actually less than 9, so we can't make a triangle from those three measurements. Okay. 4 and 6, if we add them together, gives us 10, which is greater than 9. So there we can definitely make a triangle with the side lengths 4, 6, and 9 yards. So that definitely makes a triangle. Okay, the last example for today. If I have a triangle that has side lengths of 4 inches and 7 inches, what is the range of possible lengths for the third side? So when I add the two smallest together, it has to be greater than 7. So when I add those together, it has to be greater than 7. So what you do is you go ahead and subtract 7 minus 4, and that gives us 3. Okay, so it's got to be greater than 3. So my side is greater than 3. And then if I add them together, that could give me another option for my third side. 4 plus 7 is 11. So it can't be greater than 11. So my side lengths are between 3 and 11, and we can write it as that compound inequality. And we're done. So anything in between that will work for the third side. It could be 3.001, and that works. Okay, so today we looked at the comparison property of inequality. We looked at the corollary, the remote angle theorem, that says that the exterior angle is always bigger than each of the other angles. Do not make me yell at you while I'm recording this video. Okay. And then we talked about the relationship between the sides and the angles of a triangle. Okay. And lastly, we looked at whether or not a triangle can be made from the three side lengths. Have a great day, and you got any questions, I will answer them in class.